Welcome to the Explainer. Okay, let's dive in. For a long time, if you wanted to get good at AI, you had to master prompt engineering, writing that perfect set of instructions. But that's all changing, and fast. We're seeing this huge shift away from just writing prompts to something way more powerful, something called context engineering.
So to really get what this is all about, let's kick things off with a pretty wild example. Picture an AI playing a game like Catan. And I'm not talking about a quick game of chess here. This is a 75-minute-long beast of a game, all about strategy, negotiation, and managing your resources. The AI needs to remember a trade it made an hour ago and keep track of what everyone else is doing the entire time. So the question is, how in the world does it pull that off? And that question right there gets us to the absolute heart of the problem for anyone trying to build an AI agent that can handle these long, complex jobs. It all boils down to one thing: memory. See, every single AI works inside something called a context window. The easiest way to think about it is like it's short-term memory. It's all the info the model can see at any given moment to decide what to do next. But here's the catch, and it's a big one. That memory is limited. And that limitation leads to this problem that developers call context rot. Basically, as you cram more and more information into that context window, every single move in that Catan game, every line of code it's writing, its ability to pinpoint the important details starts to, rot. It just gets worse and worse. The analogy is perfect. It's like trying to find one specific Post-it note on a desk that is absolutely buried in papers. The folks at Anthropic have a great way of putting this. They say that just like us, these large language models have a limited attention budget. And every new piece of info you give it, it spends a little bit of that budget. Pretty soon, it gets harder and harder for the AI to focus on what actually matters. So, what's the solution here? We can't just make the context windows infinitely bigger, right? That's not practical. It means we need a totally new approach, a whole new way of thinking about building with AI. And that's exactly what's happening.
And this is the big shift we're talking about. We're moving from prompt engineering to context engineering. So prompt engineering is all about writing that perfect one-off instruction to get the best single answer. But context engineering, that's totally different. It's about getting the best behavior over a long series of steps. And you do that by actively managing all the information the AI is seeing. It's not a one-and-done thing, it's a continuous, ongoing process.
Okay, so that sounds great in theory, but how does it actually work? What are engineers really doing to manage this attention budget for an AI?
Well, it really comes down to three main techniques. Think of it as the context engineer's toolkit. It's basically about helping the AI organize its own thoughts through summarizing, taking notes, and delegating. Let's dig into each one.
First, you've got something called compaction. This is basically like cleaning up the AI's desk. When its short-term memory starts getting way too cluttered, the system makes the AI pause, summarize the most important stuff, and then start over with a fresh, clean slate. Just that key summary. All the old, useless clutter, gone.
Second, there's structured note-taking. This is exactly what it sounds like. The AI basically keeps its own diary or a running to-do list. It jots down important info or updates to an external file that acts like a long-term memory. That way, even if its short-term memory gets wiped, all that crucial knowledge is safe and sound.
And number 3 is what's called sub-agent architectures. I love this one. Think of it like a manager who delegates specific research tasks to their team. You have one main agent that's in charge of the big picture, and then it sends out these specialized sub-agents to do the heavy lifting on focused tasks. Those sub-agents use up their own attention budgets, and then they just report back a simple summary to the boss. This keeps the main agent's attention sharp and focused on the goal. And this stuff isn't just theory anymore. These techniques are actually being built right into the tools that developers are using today to make AI agents that are way more powerful and, frankly, just more reliable. Take Anthropic, for instance. They're putting these ideas right into the toolbox for their Claude AI model. They've got something called context editing, which is basically automated compaction. It just cleans out the old junk when the AI's memory fills up. And then there's the memory tool, which gives the AI a ready-to-go system for that structured note-taking we talked about, like its own personal hard drive to save and pull up notes. Okay, so what does all this mean in the real world? Like, what actually happens when you give an AI these tools to manage its own brain power? Well, the jump in performance is, honestly, it's pretty staggering. Let's look at a really long, complicated web search task. Just by using that context editing tool, the AI had to process 84% fewer tokens. That is a massive reduction in noise. And it's not just about being faster or cheaper, It's about freeing up that precious attention budget so the AI can actually focus on solving the problem, not just wading through clutter. And of course, that translates directly into better results. For a really tough, multi-step job, just adding context editing boosted the agent's success rate by 29%. Then you throw the memory tool into the mix, and that success rate jumps by a full 39% over the original. That is a huge leap in what these agents can do. So we're not just talking about a small improvement here. This unlocks completely new kinds of jobs for AI. I mean, think about it. Agents that can work on enormous code bases without losing track of what they're doing, research agents that can read hundreds of documents and actually build up knowledge over time, or data agents that can chew through workflows that are way bigger than any single context window could ever handle.
At the end of the day, what it takes to build a really capable AI is changing. It's not just about writing the perfect prompt anymore. The real challenge, the real engineering work, is now about thoughtfully managing what the model pays attention to at every single step of the process. So by treating an AI's context like what it is, a precious, limited attention budget, we're unlocking a whole new world of possibility for what these agents can do. And that leaves us with a really exciting question to think about. Now that AI can actually remember and plan and learn over long stretches of time, what are the really big, hairy, complex problems they're going to solve next?